Alright, what up? So we're going to do 3 mathematical tricks. And I just got this book. My brother got it for me. And hell yeah. And he says if we use that book, we could do this book. So that's what we got going on. Anyway, hell yeah. So this video is mathematical tricks, and there's 3 of them. And they all involve a number 1 in the numerator. Or involve number 1 and manipulating a little bit. And so, I mean, you could say that the number 1 is just the number 1 is an imaginary number. Its imaginary component is just 0. You know, you don't think of it like that, but hell yeah. So simple, and first up is that if we have a y is equal to 1. This one drove me nuts because I know that it's just a horizontal line that's flat and at the y-intercept of 1, but it doesn't feel like I can input an x. I don't see an x here to input, so that drives me crazy because I know a function is like inputting an independent variable. Like if I put in the number 3, the output is 1, and I don't see that, and so I wanted to have a method where, like, hey, if I plugged in a value of x, it's still the output is 1. And this is what I came up with, is just use the equation for a line. Y is equal to mx plus b, and your slope is just 0. So there's our x component, and then so that's how we write it. This function, so now we can see that it's a function of x. I can put x, any real number between negative infinity and infinity, and I'm going to always output the number 1. Alright, so trick number 2, because first up in this book was learning series and reviewing series, and I couldn't see this. I could see what's happening in the denominator. You know what I mean? Maybe something is getting squared, like 2 to the first power. I can see that, and I can see this is 2 squared, and I can see this is 2 cubed, and so on and so forth. What I cannot see is this next jump. I don't see how this is the whole thing. 1/2 to the first power, 1/2 squared, 1/2 to the third power. Just because everything's going on downstairs. And it's because the numerator is 1. If we square, you know what I mean, for this one, if we square that numerator, the numerator stays the same, and that's why we can do this. So this is just a note to self, hey, do this intermediate step. Like if to go from here to here, because there'll be probably times where I forget this. You know what I mean? So how could I easily get from here to here? Well, we're just going to be like, well, can I manipulate this number 1 so it's more useful to me? And yes, I can square it in all 3 cases. And then one of the properties of powers is that if I have you know what I mean? And this works with a squared b squared. That's going to be ab squared. Or, so this is product rule and a quotient rule. A squared divided by b squared is a divided by b all squared. And so that's what we're doing here, and that's useful. All right. Third one up, this was more complex. This was last night. For the life of me, I couldn't figure out how to do partial fractions. And it's one of those things where I just don't want to go to YouTube and be like, you know what I mean, what up? And so, but we had to, you know, or Google, I guess. Hell yeah. And so we had this. We have 1 divided by n squared minus 4. And we're going to try to take the integral of it. And we know that if we do a u substitution, we're going to have a du component that's going to be 2n, you know what I mean? Because if you take the derivative of this, it's 2n, you know, and this goes to 0. But I don't see any other n in here, and so I have to break this up. The first step is I can break it up like this, and then partial fractions says that I can have this equal 2 different things. I can have it equal a variable a, which is just a number. So a divided by this n plus 2 plus b divided by n minus 2. I just don't know what a and b is. And then for the life of me, I could do that, but I just couldn't figure out this next step. I just see a number 1. I And then, so making this video is just like, oh, no way. This is such the aha moment, because now I'm going to make this number 1 look like what we did over here, 0x plus n. Our independent variable is n. So I'm going to say this is 0n plus 1. But see how this number 1 is 0n plus 1, and how this function of x is equal to 1 was 0x plus 1. So that's kind of mic drop on that. I just thought that was very sweet. Now is the motivation to show like at least 3 tricks in this. Okay, hell yeah. And now, and it might still not be obvious, but we need to get the denominators all the same. So we have to multiply top and bottom of this one by n minus 2, and top and bottom of this one by n plus 2. And then the denominators will be the same. I'm going to make this symbol anytime that I break away from the original equation, and I should almost do this symbol as well, because, you know, we're trying to solve for this. Once we get a and b, like, hey, this is what we're going to try to solve for, and I can do these integrals. U substitution, my du is just going to be, this n's going to go to 1, and then my u substitution is just going to be a du, and then that, I do have a constant up top. So hell yeah. So just to let you know, when we solve for a and b, they're going to go back into this equation. And I think for me, I'm going to use this. Anytime that I break away from like the original equation I'm going to try to solve, or we're going to solve sub-components in this, because now I'm just going to solve this piece is equal to these 2 pieces. You know, forget the integral. And then going to this step, I'm going to forget the denominator. All I'm going to show is that 0n plus 1 is equal to, you know what I mean? And then the numerator changed. Because if the denominators are all the same, this a picks up a n minus 2, and this b picks up a n plus 2. Okay, hell yeah. And then we're going to factor that. So we have an minus 2a, bn plus 2b. And then we're going to group the n's together because we have 0. You could consider this a group of 0 n's, or 0 times n. And so we have, sorry for moving this, so we have a plus b, so n, a plus b. So if we get this an plus bn, and then factor out the n, that's what we're doing. We're going to get 2b minus 2a. I'm going to put it in that order just because that's how books will do it. It'll make more sense. But hell yeah, and then factor out the 2. You don't have to do that at that step, but whatever. 2b minus a. This whole thing is a constant, and then this whole thing is, so this thing is related to this, and then this thing is related to this number. So I'm going to do 2 separate equations, use this symbol. I'm going to have a plus b is equal to 0, and then I'm going to have 2b minus a is equal to 1. And then just solve 2 simple equations. And so I'm going to say a is equal to negative b, get that, and then this one is going to be 1/2, so b minus a is equal to 1/2, get that 2 downstairs. And then this a, I'm going to sub in negative b, you know. It's a negative minus a negative, so it's a b plus b. It's going to be 2b is equal to 1/2. This 2 goes downstairs. B is equal to 1/4. A is equal to negative 1/4. And now we can throw those values in. And this one was very useful to actually, I made mistakes. Like, my mistake was, I'd said this was n plus 4, n minus 4. And then I just, for the life of me, I couldn't figure out what the hell mistake I was doing because all my graphs weren't lining up. And so it's just really good then to go back to here. Anytime that you're, okay, so this is, we're done with our 3 tricks, but this is just a little bonus, and it's very useful. When you have an equation, this equal sign is really important because I'm saying this is equal to that, and you're always doing mathematical manipulation. I can graph this, and that's what we're going to do right here. And then if I graph this, if I do some sort of math, but I'm saying this is equal, then it's got to be equal. 1 divided by x plus 2, x minus 2, and this better overlap. So that's just a real quick way to do that. And we can even do this one because I'm saying this is now equal to this. My a is negative 0.25, and this better be you know, this is a drum roll moment. I don't know. I could have made mistakes. X plus 2, And but yeah, such a fast way to check answers. I think it's really good, and it's just good to do a graphical way as well. I threw that in real fast, but hopefully it overlaps, and it does. So pen drop on this one. Trying to get better. I don't know. Just trying to make money at this. Anyway, so your likes and comments always help. You know what I mean? If I feel like we're doing it, we're doing it. And so I think we're doing it. All right, hell yeah. Thanks for joining me. And again, if this hell yeah, makes your day a little bit better, always, you know what I mean? Make a comment. Comment hell yeah. And then I'll give it a heart. Booyah.